Today we're going to look at 4.7 on parallel lines. The objective of this section is that you'll be able to find the slope of the parallel line and that you'll be able to write the equation of a line parallel to and through a given point. Our two standards, we've been dealing with these most of the unit, FIF4 and FIF8. Again, FIF4 dealing with the key features and FIF8 being able to translate between different but equivalent forms. So let's look at why lines are parallel. Picture here we see two lines, the red and the blue. Why are these two lines parallel? Well, we got to go back to what the definition of parallel means. And parallel means that two lines will be the same distance apart if we look at the perpendicular line between them. So this purple line here and this purple line here will have the same length along the entire line. Now, that's the geometry definition, and we're going to deal with that more when we go to geometry. But in Algebra 1 and in Foundations, there's some characteristics of parallel lines that we're going to look at that make this really easy for us. So let's look at those. These graphs, one thing we want to notice is the slopes. That's one of the things that we deal with in this entire unit, is slopes of lines. So if I look at this line here, I take this point, and I take this point, I can go up 4, right 2. And if I look at this line, I can go from here to here, and I go up 4, right 2. And so we see that the slope of the blue line is 4 over 2, which is 2. And that the slope of the red line is also 4 over 2, so it's 2. So when we have parallel lines, the slopes are going to be what? The same. And so that is the key thing to know from this section, is that parallel lines have the same slope. And so let's look at some lines, some equations of lines, and see what that means to these equations. So in these examples, we want to find the slope of the line parallel to the given line. Now, we could be given the equation like in example 1 and 2 here in slope-intercept form, or we could be given in standard form or in point slope form. And we need to know where the slope is located in those forms. But since this is in slope-intercept form, remember that the slope sits here. And this is your y-intercept, of course, the b. And so what is the slope of this line? Well, the slope of the original line, we'll call that m1, is equal to 5. But the slope of a parallel line, we just said a moment ago, has to be the same. And so the slope of a parallel line, this is the symbol for parallel here, the slope of the parallel line would be the same, and it would be 5. And so if I wrote an equation like y equals 5x plus 3, that would be parallel to y equals 5x minus 1 because they have the same slope. Let's look at example 2. What's the slope there? Well, the slope there is what? A half. We don't care about the y-intercept. The only thing that we'll care about it is that these two lines won't be the same line, because to be parallel, you have to have distance apart from each other. But a parallel line would have what slope? Well, we said it'd be the same, so it's also a half. And so, for example, we could have y equals 1/2 x minus 7. Again, those two lines would be parallel. Now let's look at example 3 and example 4. In those two examples, it's in standard form, so we've got to do a little bit of work to find the slope. We've got to solve it for y. And so my first step, minus the 2x from both sides, that will cancel, gives us negative 3y is equal to negative 2x plus 10. And then I'm going to divide both sides by the negative 3. And remember, what you do to one side, you have to do to both, right? And so this will cancel, and we're given y is equal to 2/3 x minus 10/3. And so what is the slope here? Well, the slope, m1, is equal to 2/3. And so what's our parallel slope? Remember, same slope, right? So it's got to be the same value. So it would be also 2/3. Let's look at example 4. Well, in this example, we've got to, again, get this y by itself so we can get into slope-intercept form. And so my first step will be to subtract the 5x from both sides. So I get negative y is equal to negative 5x plus 8. That's not a negative there, that's just plus 8. And now I need to divide by the negative that's in front of the y here. And so dividing both sides by -1, because remember that there's a 1 right there. This will cancel. And I get y is equal to 5x minus 8. And so my slope of the original line, my m1, is equal to 5 in this case. And the slope of a parallel line, again, has to be the same, so it is 5. All right, so that's what we're looking at in these lines. Now, that's just pulling the slope out of it. But what we're really going to want to do is be able to find two distinct lines on the coordinate plane. One that's originally there, and a second one that we said is parallel through a particular point. And that's what we're going to look at next. These two examples, we're going to write the point-slope form of the equation of the line described. Remember that point-slope form is y minus y sub 1 is equal to m times x minus x sub 1. And so we're just going to take our information. We have our point already. This is our x sub 1 and y sub 1. And my slope of the original line is 3. So m sub 1 equals 3. But also my m of the parallel line is 3, right? So we're going to take this point and this slope and plug it into point-slope form. So y minus our y sub 1 is 5 equals our slope is 3 times x minus -2. Simplifying the signs, y minus 5 is equal to 3 times x plus 2. This here is the final answer in point-slope form. Pay attention to what form it's asking you to give the final answer in. Okay. Now let's look at example 7. In example 7, it asks it for through the point 7, -1, and parallel to y equals 5. This one's a little different. Remember that if I just have a number, y equals 5, what type of line is that? Well, it's a y line, so it's horizontal, and it's equal to 5. So that means it's going to go through the y-axis at 5 and has a slope of what? This line has a slope of 0, which means my parallel line shall have a slope of 0. I'm going to plug that in to our point-slope form. And so y minus, this is our x sub 1 and y sub 1, so y minus -1 is equal to 0 times x minus 7. So y plus 1 is equal to 0 times x minus 7. And so technically this is the point-slope form of the line. Could we simplify it further and make this a little bit easier? Yes. And so doing that, 0 times all this will give us 0. So y plus 1 is equal to 0. Subtracting the 1, we get y equals -1. So that would be the final equation of this line. Is it point-slope form? For the most part, not really, because it's not in this technical setup. But when it's a horizontal line, we just want it y equals the number. We don't want anything complicating us in the end. Okay. Let's finally look at examples 7 and 8, where we're not going to stop at point-slope form, but we're going to continue from point-slope form into slope-intercept form. So let's look at those problems. 7, we're asked to find the line that is parallel to y equals -2/3 x minus 1 and has the point 1, -3. And we want it again in slope-intercept form. And so we're going to take the slope from this line. So our m sub 1 is -2/3, which means my parallel slope is also -2/3. And we're asked to go into slope-intercept form. We actually want to start in point-slope form because I have a point that is not the y-intercept. And so I'm still going to start y minus y sub 1 is equal to m times x minus x sub 1 with the goal of getting this solved for y so I get it into slope-intercept form. And so y minus our y sub 1, which is -3, equals our m, which is -2/3, x minus 1. So y plus 3 is equal to, we're going to distribute this and get -2/3 x plus 2/3. I need to subtract the 3 across, so y is equal to -2/3 x, positive 2/3 and -3. So if you forget how to deal with fractions, remember we need a common denominator And so 3 over 1 will become 9 over 3. And so that's going to give us minus 7/3. That's the final answer here. Again, if you struggle with fractions, come talk to me, but we got to be able to work with these at the high school level, okay? And so finally, our last example, example 8, through the point 4,1 and parallel to y equals 5/3 x. And so in this form, remember, there's an x sitting here, which means if it's attached to the x, it's our what? This is our slope. So slope 1 is 5/3, and our slope parallel is 5/3. This is our point, x sub 1, y sub 1. Again, we're trying to get into slope-intercept form, so we want to start in point slope, and then convert over and eventually get into our slope-intercept form. And so y minus 1 is equal to 5/3 x minus 4. We're going to distribute this, so y minus 1 is equal to 5/3 x minus, remember this is over 1, so 20 over 3. And we're going to add the 1 across. That will cancel. So y is equal to 5/3 x negative 20/3 plus, again, we're going to change this over, so this will be 3/3. That'll be minus 17/3. That's our final answer there. That's what we're looking at in this section. Again, be able to write these lines as they're parallel to other lines, understanding the slopes that they have and the slopes that are related to. So that's it for today. I hope you'll have a good one, and I'll catch y'all next time.